Hey guys, so now that we've talked about the rules of limits and how to compute limits, we're going to talk about a specific type of limit, which we're going to call the infinite limit. So let's jump straight into some examples of how the infinite limit can be recognized and do some practice on it. So here we have the infinite limits are when you get blank or blank. And that is going to be, is actually in the name of infinite limit, whenever you get negative infinity or positive infinity. Alright, that is the first point about infinite limit. So whenever your answer is negative infinity or positive infinity, you're dealing with an infinite limit. Alright, so the next thing is going to be, which type of asymptote do you care about when you're talking about an infinite limit? So when we're talking about when we introduced limits and we had all these graphs, right? Remember that when we would try to reach a certain x value and then we couldn't get a finite answer, we would kind of like just follow the graph and it'll take us infinitely up or infinitely down, infinitely up or infinitely down. If you guys see, what we care about here is going to be our vertical asymptotes, because the vertical asymptote is what can take you infinitely up or infinitely down. Alright? So we care about the vertical asymptotes, and they're an example of an infinite limit, right? So now let's jump into an example of this when we're given 1 over x, which is a graph that we have seen before, and we've discussed its vertical asymptotes, right? So let's kind of draw a quick sketch of what the graph is supposed to look like, and have its. Let's do a darker red. Maybe not. Here we go. There we go. So now we have darker lines for red. So we know these are the asymptotes of 1 over x, because we've dealt with this function before. And then we know the graph kind of looks like this. And now let's go into this part here where they ask us to compute the asymptote from the right. Okay? So we're gonna approach 0 from the right of f of x. And in this case, f of x is 1 over x. So I do know that doing all this limit stuff is a little painful, mainly because calculus is helpful when you don't have a calculator. But when you have a calculator, you can just plug in the function, look at the graph, and just like drag your finger up and decide the answer, right? So I know it's kind of annoying that we have to do all this stuff by hand, but the point for calculus is if we don't have a calculator, how do we analyze functions, right? So here we're going to analyze this function as if we didn't have a calculator, right? As if we didn't know this already, as if we didn't have this graph already, right? So let's go ahead and do that. So I'm approaching 0 from the right. I'm going to bring up something like a little technique here, which is going to be the number line, right? So if I want to approach 0 from the right, I'm going to care about the values that 0 has from the right, which are going to be 1, 2, and 3. So I'm just going to pick easy 3 values to work with, right? So I'm going to actually plug those values into my equation, right? So as I'm approaching 0 from the right, I'm going to care about 1, 2, and 3. So I'm going to compute 1 over 1, 1 over 2, and 1 over 3, right? So you may or not know the answers, the decimal places to these answers, right? To 1, 1/2, and 1/3. But if you don't, I'll give them to you. This is 0.33, this is 0.5, and this is just 1, right? So the question is, as you're approaching 1, as you're going from 3 to 1, as you're approaching 0, so you're going 3, 2, 1, 0, as you're getting to 0, right? What is happening? So as you're traveling this way, right? As you're getting closer, you're going from 3 to 2 to 1 to eventually get to 0. As you're getting to 0, what is happening to your values, right? So what's happening to your values is that they're going from 0.3 to 0.5 to 1. What's happening? They're getting bigger, right? And we can see it in the graph, right? So let's say this right here is like 1, this right here is 2, and this right here is 3. So we can see that at 1, we can say that we're at 1. At 2, we're at something like 0.5. And at 3, we're here at 0.3, right? So we have drawn the points, right? So as you're going to 0, as you're approaching 0, your values are actually getting bigger, right? Your values are getting bigger. So that means that you're going to go up bigger in a positive way. So you're going to go up positively and follow that asymptote. That means you're going to go eventually to positive infinity. Okay? Because if you think about it, you're going up in a positive manner, and then you're on the asymptote. You're on the vertical asymptote. So if you're going up, you're not going to get to a number. You're just going to keep going eventually all the way to positive infinity. So the idea here to do is that you have to input numbers, the direction that you're trying to approach. So that's why I always like to draw a number line and show that you're approaching 0. So you're going to approach 0, and then you're going to input those numbers and see how those numbers change. If they're getting bigger, and they're getting more positively bigger, then you're going to go to positive infinity. If they're getting bigger, but they're negative, they're big negative numbers, you're going to go to negative infinity. And if they're getting really, really, really small, then eventually you're like, oh, maybe they're going to 0. Okay? So let's go ahead and try the other part, where you approach 0 from the left. And that means that let's do this in red, or maybe green to switch it up. And we're going to go to 0 from the left, which means that we're going to go from -1, -2, -3. So I'm picking easy numbers. We all know how to work with -1, -2, -3. And we're going to input those numbers and see as we approach 0 from the left side. So we're going this way. As we approach 0 from the left side of the number line, how do my values change? What is happening? So I'm going to have 1 over -1, because I'm inputting into my function 1 over x, 1 over -2, and 1 over -3. So I'm going to get the same values, right, but negative. So I'm going to get -0.33, -0.5, and just -1. So what is happening to my values as I'm getting closer to 0? So as I'm going from -3 to -1 to from -3 to -2 to -1, my numbers are getting bigger. They're going from 0.3 to 0.5, from 0.5 to 1. They're getting bigger. So what is happening when these numbers are getting bigger, but they're getting bigger in a negative way? I'm going to go to negative infinity. I'm going to approach negative infinity. And we're going to show that in our graph. As we are in if we're in -1, let's say we're here at 1, we're at -2, we're here at 0.5, and then we're at -3 here, we're at 0.33. So as I'm going to 0, I'm trying to approach 0, I'm eventually going to go down to a very big negative number, which I'm going to call negative infinity. So I hope this number line trick and inputting numbers and seeing how the numbers change as you travel to the number you're trying to approach makes sense. And we're gonna try more examples on this stuff. So when we switch it up, when it's not just 0, because a lot of times the limit is as you go to 0. So let's see what happens if you approach a different number, not just 0, right? And also remember that if you guys have any questions on this, just feel free to ask on the left-hand side of this app, and I'll answer any questions right away. So let's do example 2. And actually, before we jump into example 2, there's one last question I can ask about example 1. And that is going to be, if you guys remember from the introduction to limits, I can ask you, what is the limit as x approaches 0 of 1 over x? So if you guys remember, to get the limit as x approaches 0, since when we input it we have a problem. You guys see if we input 0 into our function, we're going to get 0 on the bottom. We know it's in a vertical asymptote. So right there tells us we have a vertical asymptote. Right? So we need to check the left side and the right side, right? So we have that on the right side, our asymptote is positive infinity, but on the left side, our asymptote is negative infinity. So then we say that since these two answers don't match, our answer is does not exist or D&E. So we don't have a limit. So if I were to ask you, what is the limit as x approaches 0 of 1 over x, and you recognize that 0 is a vertical asymptote of your function, then you have to go ahead and compute a left side and a right hand side limit and see those two limits equal each other. And that's going to come in very helpful when they just tell you find the limit as x approaches x number, whatever this number is, and it gives you a vertical asymptote. What do you do? Well, what you got to do is you have to check if the left and the right equal each other, and then whatever that answer is, if it matches, it's that answer, and if it doesn't match, is D and E or does not exist. So we'll do a little more examples on this stuff, and you guys will get very familiar with it. But I just want to make sure that you guys can transfer this information of the one-sided limits from left side and right side to they're actually asking you a two-sided limit. So you need to actually compute two one-sided limits, the left side and the right side, in order to answer a two-sided limit, which is what we have here. Here we have x equal to 0, which is a two-sided limit, and then we have one-sided limits here. Okay? So now let's move on to example 2. So here, in example 2, I'm going to give you 2 over x minus 3. So if you guys recognize, this is going to be a function with a vertical asymptote of, it's going to have a vertical asymptote of x equal to 3, right? You just set the bottom equal to 0. But let's say you didn't know that, okay? So now we're going to play it a little dumber, and we're going to say that, oh, we don't know that. So how do we use calculus? How do we use calculus to realize this, right? So let's now approach, let's approach 3 from the right. And the values that I'm going to pick from the right are just going to be 3 values. You can tell enough if you have 3 values, in my opinion. If you need more than that, go ahead. But with 3 values, you're good to go. So here we're going to have 4, 5, and 6. So what this means is I'm going to input 4, 5, and 6 into my equation. So I'm going to have 2 over 4 minus 3, 2 over 5 minus 3, and 2 over 6 minus 3. So I'm going to have 2 over 4 minus 3 is 1. And then here I'm going to have 2 over 5 minus 3 is 2. And then here I'm going to have 2 over 6 minus 3 is 3. So this is 2. 2 over 2 is just 1. And 2/3 is 2/3, or if you guys plugged into your calculator, is 0.6. Well, you guys may already know this because you guys memorized this number from using it so much. So whatever the case is, we need to look as you're approaching 3. So how does it change from 6 to 5 to 4? So you go this way, right? As you approach 3, how is your number changing? You're going from 0.6 to 0.1 to 0.2. So that's going to be, your number is getting bigger. So if your number is getting bigger, you're going to say you're going to, bigger in a positive way, you're going to go to positive infinity. Okay? So now let's kind of plot that and we can see what's going to happen here. We plot 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We're actually going to plot these numbers. 4, 4, 2. It's going to be right here. 5, 1. And then 6.6. So as you guys see, your function is going up. If we plot those points, it's going up, right? And let's now get a little smarter, and we're going to say that yes, we have a vertical asymptote at x equal to 3, because we said the bottom equal to 0. So you see here at 3, we have an asymptote. We just care about the vertical asymptotes for this stuff. You're eventually just going to do what? You're going to go up. So you're going to follow your asymptote and go to positive infinity. Okay? So now, let's do the one from the left. So from the left, we're going to try the values 2, 1, and 0. 3 points, we're good with that. Let's go ahead and input them. So we're going to have 2 over 2 minus 3, 2 over 1 minus 3, 2 over 0 minus 3. So here we're going to have 2 over negative 1, 2 over negative 2, and 2 over negative 3, which are the same values we're going to get on the other side. They're going to be a different sign. Negative 2 over negative 2 is just negative 1, and 2 over negative 3 is just negative 0.6, right? So we're going to draw the same thing, but opposite values. So at x equal to 2, we're going to have negative 1. And then at x equal to 1, we're going to have negative 1. Wait. At x equal to 2, we're going to have negative 2. My bad. So at x equal to 2, we're going to have negative 2. And then at x equal to 1, we're going to have negative 1. And then at x equal to 0, we're going to have 0.6. So as you guys can see, this line is like sloping down. It's going to follow our asymptote. So we can tell where it's going already from the graph. But let's look at the numbers, because this stuff is all about the numbers, not about the graphs anymore. But we're using the graphs to help us to slowly let go, and we can just go straight into numbers. So it's going from negative 0.6 to negative 1 to negative 2. So the numbers are getting bigger, but getting bigger in a negative way. So we're going to call it negative infinity. Okay? And also, another thing that I wanted to say is don't assume because we're going to that we're approaching from the left that we're going to get a negative number, and that if we're approaching from the right, we're going to get a positive number. All this can be switched up on us depending on the graph, or depending on the function, which the function establishes the graph. So don't make these assumptions, because it's very easy for the professor to switch it up on you and just be like, bam, tricked you. All right. So let's go to example 3, where we're given two types of asymptotes. We're given two types of vertical asymptotes. We're giving x equal to 0 and x equal to 2, right? We said x equal to 0, and then x minus 2 equal to 0 gives us x equal to 2. So we have two types of asymptotes here. Let's draw like a thick line here at 0, and then now at 2. Okay? So let's go ahead and do that. And we're not like crazy familiar with how these graphs look, right? The ones that have two asymptotes, because they have different combinations that they can go. We can't just be like, oh, it's like this and like this. Then what happens in the middle? Or like, is it even like that? Is it somewhere different? So we don't know. So we're just gonna use calculus. You see, we're gonna use that calculus limit part of this portion to see how the graph behaves, right? It's all about how the graph looks. And ideally, what we want to do is just use all these different techniques in calculus. Later on, you guys will learn about derivatives in order to be able to just completely draw a graph with all these calculus techniques without using a calculator. So that's the idea, right? So here we're just dealing with limits, which are going to tell us how the graph behaves as you approach that number. So in this case, we're going to see how the graph behaves as you approach 0 from the right. So you want to know what is happening as you approach 0. Is your graph going to go like this? So the questions are, is your graph going to go like this, or is your graph going to go like this? Because you got to follow your asymptote. So how is it going to go is the question, right? We don't know. So let's just plug in some points and we'll see. So we're trying to go to 0. Oh, we're trying to go to 0 from the right. So actually, that was from the left. So we're trying to go to 0 from the right. So are we going to go, again, are we going to go like this? Are we going to go up? Or are we going to go down 0, right? That was our question. What are we trying to do? So here we're going to go to 0 from the right. So let's plug in numbers such as 1 and 2. But 2 wouldn't be a good idea, because if we plug in 2, it's going to be another asymptote. So let's plug in smaller numbers in this case. 0.1, 1, and 1.5. Okay, so in this case, we're going to plug in different numbers, and we're going to see how it works. So we're using the same three number method, but we're going to modify the numbers that we put in, because we just need to know what's going to happen. So here we're going to input 0.5. So 0.5 times 0.5 minus 2. The next one's going to be 1 minus 2, and the next one's going to be 1.5 times 1.5 minus 2. So let's go ahead and solve these numbers. It's not going to be the easiest numbers because they're decimals and all this stuff, but let's give it a shot. We just care about, we don't even care about exactly the number, we just care about how it's behaving, right? If it's getting bigger or smaller. So here we're going to have 0.5 times 1.5. Here we're going to have just 1 times negative 1. So, and then here we're going to have 0.5 times positive 0.5 times positive 1.5. So I actually forgot a little sign here. This is actually going to go to negative 1.5. So here we have 1 over 0.5 times negative 1.5. So let's say you don't have a calculator. That's equivalent to 1/2 times 3 over 2. 1/2 times 3 over 2. Right? 1/2 is 0.5. And 3 over 2 is 1.5. So that gives us 3 over 4. So I'm teaching you guys how to do this without a calculator, right? So we have pretty much here 1 over 1 divided by 3 over 4. Then we're going to flip it. So what we're going to do is we're going to see how we go to 4 over 3, which is equivalent to 1.33. Okay? We just kind of flip it when we're dividing by fractions. And now here we have 1 over 1 times negative 1, which is just negative 1. And here we're going to have exactly the same number. Oh, this is negative 3 over 4. So it's negative 4 over 3, so negative 0.33. Here we're going to have exactly the same number. We're going to have negative 4 over 3. I mean positive 4 over 3. And it's going to be positive 1.33. Okay, so as we're going to 0, we see that our number is getting actually bigger because it goes from negative 1 to negative 1.33, but it's getting bigger in the negative way. So from here to here we lost the positive number, so we're getting smaller, but now we're actually getting bigger in a negative way. So since we're getting bigger in a negative way, it's going to be negative infinity, which means that our graph is going to behave this way. Okay? And now we're going to go into the other one, which is as we approach 2 from the left. So now we know that the graph is going to go like this, right? But now we're going to see how you approach 2 from the left. So what's happening? Are you going to keep going up here, or are you actually going to go down here? How is your, let's put those options in green. What's happening? You know? Which one is it? So let's go ahead and pick 2 numbers. We're going to 2. I'm actually going to like erase this number line and put 2. And we're approaching 2 from the left. So it's going to be 1. Well, we can do 1 and 0. We got to do again this little point. We got to do 1.5. We have to do 1, and then we have to do 0.5. So we're going to pick those annoying little numbers that we got to do. So we're also going to plug them into here. And you guys will see that most of the time when you do left and right, the answers are actually going to be about the same. And you'll see that here we're going to plug in 1.5, and then 1.5 minus 2. Then here's going to be, you're plugging in 1, so there's going to be 1, and then 1 minus 2. And then here you're plugging in 0.5. 0.5 minus 2. So what's happening here is that as you're going to 2, right, you're going to see as you're going to 2 from the left, here you're going to get 1 over 1.5 times positive 0.5. And then we already know that from here, that's going to give us positive 4 over 3, or 1.33. And then here we're going to have 1 minus 2, so that is negative 1. So the answer is just negative 1. And then here it's going to give us 1 over 0.5. 0.5 minus 2 is going to be negative 1.5. And we know that from here, it's going to give us negative 1.33. So now, we look as you're approaching 2, so as you're going up, try to move myself there. As you're going up, what is happening to your number? It is actually, it's growing, right? And it's actually getting more positive. So you're going to positive infinity. So it's actually going to be this upper piece. This upper piece. So let's kind of redraw it. It's this little upper piece here. Okay? So we're just going to say that the graph is behaving like this. So now we have decided how the graph behaves between these two asymptotes, computing these two limits. So yes, it's a little tedious. You just got to see how it's behaving. But if you guys just plug in 3 numbers and then apply the rules of, of seeing how it changes as you approach the number, you guys should be good to go. So let's go ahead and do some practice problems on this and see how we can determine certain parts of different graphs based on the sides of the asymptote you're trying to find, the left side of the asymptote, the right side of the asymptote, or in between the asymptotes. So let's go ahead and do that, and I'll see you guys next time.